The sun is the heart of our solar system. It gives life on Earth. Without it, there would be no plants, no animals, no humanity. But what if we stop to think, how did it form? Why does it shine? What is happening in its core, and what awaits our planet when it changes? In this video, you will see how the history of the sun began, gravitational collapse and the formation of a protostar, the first nuclear fusion and the first light, the solar wind and magnetic fields, the stabilization of planetary orbits, the red giant phase and the threat to Earth, the transformation of the sun into a white dwarf, the impact on distant planets, and the future of the solar system. More than 4.5 billion years ago, in a nebula of interstellar gas and dust, matter began to clump together. Under its own gravity, the denser regions of the nebula started to collapse, forming a protostar, the future sun. This process took millions of years. Various fractions of gas and dust, including hydrogen, helium, and traces of heavier elements, began to heat up. NASA and the European Space Agency confirm observations of nebulae like the Orion Nebula show that star formation is always accompanied by rotation and the creation of disks of matter from which planets later emerge. When the density in the center of the cloud reached a critical point, gravity overcame gas pressure and a hot protostar formed. The core temperature rose to millions of degrees, gradually igniting thermonuclear reactions. While the core was heating up, the outer layers remained cold and hazy. Observations of modern protostars like H.L. Tauri show disk formation from which planets and asteroids emerge. This confirms NASA's models. The sun began as a typical protostellar object, but its unique conditions and mass determined its longevity. When the temperature in the protostar's core reached about 10 million Kelvin, thermonuclear fusion of hydrogen into helium began. The first stream of radiated light appeared, and the sun became visible to cosmic space. This was the beginning of billions of years of stable shining. NASA emphasizes the balance between gravitational contraction and the pressure from thermonuclear fusion creates hydrostatic equilibrium, which has allowed the sun to shine for more than 4.5 billion years. The early solar winds, streams of charged particles, dispersed the remnants of the nebula, shaping a stable inner part of the system. The sun's magnetic field, created by the rotation of its hot plasma core, influenced the formation of planetary orbits. This explains why planets are arranged in a flat disk and why comet tails are oriented relative to the sun. Modern studies by NASA's Parker Solar Probe have confirmed the composition and structure of the solar wind, which affects the magnetospheres of Earth and other planets. The pressure and heat from the sun determine the chemical composition of planets. Closer to it, rocky planets formed Mercury, Venus, Earth, and Mars. Farther away, the gas giants. The solar wind removed light gases from the inner system, leaving solid material to form planets. NASA and European studies confirm it was the intensity of early radiation that determined the internal composition of planets, giving Earth the optimal conditions for life to arise. The sun went through a phase as a young star with active flares and intense winds. Over time, its luminosity stabilized, giving Earth a milder climate. Plants, oceans, and the atmosphere, all of this formed under the influence of stable radiation. NASA notes that the average solar radiation power today is about 1,340 watts per square meter at the upper layers of Earth's atmosphere. The sun has active regions on its surface called sunspots. They are darker because they are slightly cooler than the rest of the photosphere, but this is where magnetic fields are strongest. Magnetic activity causes flares and coronal mass ejections, powerful plasma streams rushing into interplanetary space. When they reach Earth, they create auroras and geomagnetic storms. NASA and ESA monitor these processes with the Parker Solar Probe and Solar Orbiter because they affect satellites, power grids, and even astronauts' health. The sun does not shine the same way constantly. Its brightness changes cyclically about every 11 years, which is called the solar cycle. During maximum activity, the number of sunspots and flares increases, and during minimum, it decreases. These cycles affect Earth's climate, space weather, and even radiation levels in space. Knowledge of these cycles helps scientists predict cosmic phenomena and protect technology on Earth. At the edge of the sun, enormous spirals of plasma emerge, prominences, sometimes stretching hundreds of thousands of kilometers. They can last for weeks or even months. The solar corona, the thin outer layer of the atmosphere, is much hotter than the photosphere millions of degrees Kelvin. This is a mystery that astrophysicists are still trying to explain. Studying these phenomena provides understanding of magnetic processes and energy transfer mechanisms in stars. The sun is an ordinary star among billions in our galaxy, but for us it is unique. Studying its structure, activity, and evolution helps astrophysicists understand the life of other stars and the potential habitability of planetary systems. NASA and ESA use the sun as a laboratory for testing stellar models and predicting their future evolution. Observing our sun reveals the mysteries of the universe and the future of planetary systems across the galaxy. In about 5 billion years, the hydrogen in the sun's core will run out. The core will begin to contract, the outer layers will expand, and the sun will turn into a red giant. Its radius may reach Earth's orbit, engulfing Mercury and Venus. The temperature on Earth's surface will rise sharply, oceans will evaporate, and life will become impossible. NASA warns that even if Earth's core remains, its surface will be completely uninhabitable. Mars, or the moons of Jupiter and Saturn, could become temporary refuges. There, protected environments with controlled climate and resource supplies would be necessary. Using next-generation interstellar ships, humanity could leave the solar system and establish new colonies around other stars. This would require breakthrough technologies in travel speed and life support. In the far future, ideas of moving Earth's orbit farther from the sun are also considered, using gravitational maneuvers or giant planetary engines. This is extremely complex, but theoretically possible. NASA, ESA, and leading astrophysicists emphasize that these scenarios are still science fiction, but they show humanity's potential to prepare for cosmic catastrophes. Studying the sun and other stars gives us an understanding of the time remaining and the ways to survive in the long term. After losing its outer layers, the core will remain a white dwarf. It will cool for billions of years, its glow gradually fading. Surviving planets will orbit the cold remnant. The solar system will slowly become quiet. Gas giants, comets, and asteroids will feel the changes in gravity and thermal radiation. NASA's models suggest that the outer planets will remain stable, but some comets may alter their orbits, increasing the risk of impacts on planetary remnants. The sun will influence the whole system, even after becoming a white dwarf. The sun is more than just a source of light. It is the archive of the solar system's history, the regulator of Earth's climate, and a training laboratory for understanding stars. Today, we can observe it, study it with NASA and ESA missions, and prepare for future space journeys. Every flare, every sunspot, every solar wind carries information about the evolution of our world and the future of all planets. And though in billions of years the sun will change, its story will continue. Now, as we observe its activity, we are not only studying a star, but also preparing for the future it will bring. The sun is not only our past, it is the key to understanding the future of the universe. If you enjoyed this video and want to see more, please support our channel. Give it a like, subscribe, and share this video with your friends. For us, it is extremely important. And in the comments, write, do you think humanity will be able to survive when the sun turns into a red giant?